Welcome. We are excited to see everyone for the second International Workshop and Prize Challenge on Agriculture Vision here at CVPR 2021. My name is Jennifer Hobbs, and I'm the Director of Machine Learning at Intelinair, and we are once again excited to help organize, sponsor, and provide data for this CVPR Workshop and Challenge. Our goal at Intelinair is to organize and digitize the world's crop information and performance, and to make it universally accessible and useful to deliver high yields, efficiencies, and sustainable farming to feed humanity. By bringing together leaders from both academia and industry in venues such as this, we believe we can make huge strides in sustainable agriculture to benefit the planet. At Intelinair, we capture huge amounts of data from satellite and high-resolution aerial imagery to thermal and weather data, machine data, soil, topography, and much more. This enables us to create a digital twin of the field, which can be used to understand and analyze how management decisions impact results and efficiencies. We collect this rich data many times over the course of a season, providing key insight into the crop's health and identifying new or worsening issues that could threaten yield. In this past year, we've completed numerous projects and identified patterns of interest across the field using a variety of computer vision techniques, but today I'm just going to spotlight a few. The first project was completed in collaboration with the University of Hawaii and was published in Frontiers of Plant Science, research topic on artificial intelligence applications for specialty crop. Our aim was to identify and count all of the flowering pineapple plants in a field, which may number in the millions, and alert growers to those areas which have begun to flower or have remained vegetative and need further ground-level inspection or treatment. To do this, we collected high-resolution aerial imagery from drones, performed orthorectification and mosaicing, and annotated over 76,000 flowering plants. We used a deep learning-based counting by density estimation approach, which enabled us to count and localize the plants in the image with constant computational efficiency. Our target density map was created by blurring the point annotations with a Gaussian filter, and our UNet was then trained to predict this density map from the raw high-resolution imagery. The total count over any region could easily be computed by simply summing the density over the desired range of pixels. Our results were very impressive, both quantitatively with a per pixel MSE below 0.004 on the test set, and qualitatively, occasionally outperforming the human annotator. Finally, we embedded our model in an active learning framework to enable continual learning and model improvement, enabling us to both count and localize over 1.6 million flowering plants in just a matter of seconds, providing insight for farmers that was previously out of reach. The next project I'll touch on briefly was accepted to AAAI this past year. Similar to the work Saba is presenting in today's workshop, the goal of this work was to detect region of nutrient deficiency in the field. Damage and loss due to nutrient deficiency stress cannot be reversed, so it's critical that we identify it as early as possible so growers can make the necessary management decisions. In this work, we leverage our longitudinal data by passing a sequence of flights through a UNet followed by a convolutional LSTM. This enabled us to not only detect NDS at a very high level, but also to predict areas which were likely to experience these deficiencies several flights out. In addition to delivering a key result for the farmers, this work also highlights the importance and value of collecting multiple flights across the season and leveraging spatiotemporal approaches to extract the relevant information. The final project I'll highlight is a useful but also fun piece of work which was accepted to Frontiers in Robotics and AI. Our goal was to create a model which could be deployed to mobile to enable counting of on-ear corn kernels. Although it's a seemingly trivial task, some challenges around this task include the huge number of kernels on an ear, the presence of both healthy and diseased kernels, and the requirement to run on-device. Corn kernel counting is not a new task, but in the past many of these models have been built with proprietary data, so part of our goal was to create and release a dataset for easy comparison of approaches and also make it complex and interesting enough to engage the machine learning community. We collected a dataset of 402 images, which were annotated with dense instance-level masks. So while we focused on counting and detection or localization here, if someone's interested in doing work on panoptic segmentation, they could use this data set. We collected data from a wide domain, that is the internet and other random photos, as well as a narrow application-specific domain one might expect to see in the field, and also a many domain, which has a huge number of kernels per image to really push the limit on some of these methods. We built a variety of detection methods, including using models like FasterRCNN and YOLO v5, and can see here that they did quite well. even learning to ignore the off-ear kernels as desired. We also used a density estimation approach, similar to that which was used in the pineapple work, and again saw it perform extremely well on this task. This is obviously a useful tool for the farmers as they inspect their field, but I also encourage those on the algorithm side to check out the dataset on the AWS Registry of Open Data, because there are a lot of interesting research questions we believe this will enable people to explore. Many of the datasets I mentioned here, including the Agriculture Vision dataset associated with the original CVPR 2020 paper, as well as this year's challenge, are available on the AWS Registry of Open Data, so I encourage everyone to check those out. And finally, you can keep up to date with many of our exciting projects and announcements at insights.intelinair.com. Again, we are very excited to help organize, sponsor, and grow this workshop challenge here at CVPR. So thank you for attending and participating, and please reach out if you have any questions. Thank you.